Hey everybody, this is Alex Merced and welcome to another episode of Gnarly Data Waves. Today we're going to be having episode 8, Managing Your Data as Code with Dremio Arctic. But before we get in there, I will also point out that this is going to be our first episode since the Subsurface Live conference has happened. And there was many great sessions from Pinterest, from AWS, from Microsoft, and many more that I highly recommend that you go check on. A lot of great stuff about optimizing your data lake, about improving performance, about migration, whatever topic or challenge you may be having with your data lake or with Apache Iceberg or whatnot, there's going to be a session that's going to really help you with that. So if you head over to dremio.com/subsurface, you can still register so you can have access to all those on-demand sessions. So that again, that's at dremio.com/subsurface. But on top of that, as a reminder, the Dremio Data Lakehouse platform is going to provide you data warehouse-like functionality and performance along with data lake-like flexibility, okay? Which means you're going to have a data lakehouse that is easy, open, and fast. Now, you don't have to take my word for it. There's an easy way for you to know this firsthand, and that's by heading over to dremio.com and going for a Dremio test drive. There's no obligation. There is no cost. In a few minutes, you will be hands-on with the Dremio Data Lakehouse platform, and you can experience what all the talk is about. So go try that out. Again, that's at dremio.com. Go try out test drive. I think you'll like what you see. And of course, liking what you see, you're here because you want to know more about data lakehouses and adjacent technologies. And every week we're going to have more episodes and more presentations for you about the data lake and data lakehouse. This week we're having the Manage Your Data as Code with Dremio Arctic. Next week we're going to have Build Your Open Data Lakehouse on Iceberg with Fivetran and Dremio. So if you've ever been interested in learning more about how to ingest your data into Iceberg tables, that's going to be a good one you don't want to miss. Then optimizing data in Apache Iceberg, so things like compaction, sorting, zero techniques that allow you to make your Apache Icebergs even more performant. Okay, and Apache Iceberg office hours on April 4th. So you bring your Apache Iceberg question, we'll have our Apache Iceberg answers, and we'll see you then. And with no further ado, we're going to get into our featured presentation today, which is Managing Your Data as Code with Dremio Arctic. Presenting today will be Jeremiah Morrow, who is a product marketing director here at Dremio. Jeremiah, the stage is yours.
Hi, everyone. My name is Jeremiah, and I'm responsible for product marketing for Dremio Arctic here at Dremio. And this session is entitled Managing Your Data as Code with Dremio Arctic. Before we begin, here's a quick agenda for the session. First, I want to talk about the need for data as code and why companies are moving towards data as code for data management. Then I want to give a quick overview of Dremio Arctic. I'll talk about the entire lakehouse management service, but specifically I want to drill into its capabilities related to data as code and some of the benefits that our customers see using the service. I'll go through a few use cases where data as code makes sense, and then I'm going to pass it over to Alex to give a quick demo of the platform. So let's start with the need for data as code and why many data teams are moving to this solution. And it has a lot to do with the data explosion. Of course, we know all of our businesses are inundated with data, and it's coming from new sources than it was a couple decades ago. Back then, we were all using appliance-based data warehouses, and we were primarily concerned with collecting and analyzing structured data from business systems housed alongside it in the data center. But IDC predicts that by 2025, there's going to be 175 zettabytes of data worldwide. And a lot of that data is going to be semi-structured and unstructured data from sources outside of the data center. In fact, according to IDC, at least half of that data is going to reside in the cloud, and it will actually never see an on-prem data center. The second big trend is the explosion in demand for insights. More people across our businesses need access to data to do their jobs, and all of them need near immediate access to a consistent view of your organization's data for a wide range of analytic use cases, both BI and reporting, and also data science projects, as well as interactive dashboards and exploratory and ad hoc analytics. And the third big trend is complexity. Most of us turn to data lakes first with HDFS and then with cloud object storage as a way to efficiently store large volumes and a variety of data. But HAFS in particular was never really designed to support high concurrency and high performance analytics, and so is never able to replace the data warehouse. So what most of us have today is a really highly distributed environment with both cloud and on-premises data lakes and probably cloud and on-premises data warehouses. And most teams I talk to say that they're as far as 3 to 5 years away from a centralized data lake in the cloud. But almost none of them can afford to wait 3 to 5 years for a unified view of all of that data. And so businesses are really looking for a modern data architecture that takes advantage of the flexibility and scalability of data lake storage, delivers self-service access to data consumers with various levels of technical skill and analytic use cases, a system that can support access to data for analytics on highly distributed data sets to ensure business continuity during their migration, and all of that on a platform that makes data management easy while ensuring data governance and security, all while, of course, delivering high performance analytics on a consistent and accurate view of their data. No big deal, right? Fortunately, from a data management perspective, we have some inspiration to draw on, and that's DevOps. DevOps practices in general, and specifically Git repositories, have transformed the way developers ship and write code. Some of the benefits include CI/CD, version control, easy recovery from mistakes, and a lot more. All of this leads to better collaboration, shorter development cycles, and much higher quality products. And so companies are looking to for ways to replicate these capabilities across the rest of their IT infrastructure. And data is an area where these Git-like capabilities make it easier to deliver access to high-quality data sets for analytics. So that's the why of data as code. Manage data the same way developers manage code. And from our perspective, the how is Dremio Arctic. So this is Dremio Arctic at a high level. It is a data lakehouse management service that brings a lot of the house functionality of the data warehouse to the data lake and truly makes it a data lakehouse. It's Iceberg native, which is important for a couple of reasons. The first is that it's an open table format that is custom built for large data sets. It gives data teams the flexibility to use multiple engines, including Dremio Sonar, Apache Spark, and Flink. Just as a couple of examples for different analytic use cases, whether that's long-running ETL jobs, or streaming data, or interactive dashboards, which is really where Dremio Sonar shines. The second important aspect about Iceberg is that it delivers a lot of data optimization functionality, such as compaction and partitioning, to make sure that queries are performant even on really large tables, and garbage collection where old files are removed so that storage footprint is optimized. Arctic also features security and governance, including row, table, and column level access controls, and integration with user directories like Okta and Azure Active Directory. So that's Arctic at a high level, but in this session, I really want to drill into data as code. So Arctic uses Git-like concepts such as branches, tags, and commits to easily work on data in isolation, to track and make changes to tables, and then make atomic updates so that users see one consistent version of the data. This enables data teams to work on data in isolation without impacting the production data set, and check for quality before exposing that data to end users in a main branch. It enables version control and governance. Users can quickly reproduce models and dashboards based on historical data. Organizations can easily recover from mistakes, and all changes are tracked so data teams know who accessed what data and when, and who is making commits. Another really important concept in this is the idea that branches, tags, and commits are a no-copy solution for data management. Data copies represent one of the biggest risks in delivering a consistent view of the data. So while many other systems create separate copies of data and folders to represent different versions, Dremio Arctic uses this idea of snapshots to represent the complete state of a table at a particular point in time. Changes to the data aren't new tables. They're not copies of the data. They're snapshots, and that snapshot stores only the changes that were made from the previous snapshot. So in these terms, a branch isn't a copy of the data. It is a pointer to a specific snapshot in history. When you create a new branch, you're creating a pointer that starts at the current snapshot. And so you can make changes independently of the main branch and create multiple branches. You may have your main branch, which is your production data set that everybody's accessing and using for analytics. You could have an ETL branch to bring new data in before you and test for quality before you move to the main branch. You could have an experimental branch for one of your data scientists if they want to do some sort of transformation and they don't want to impact everybody else's data set. And all of that is working off of the same iceberg table. Tags are used to mark specific snapshots in the table's history, and it enables collaboration, version control, auditing, and a lot more by making it very easy to reference specific points in a table's history. And finally, commits are individual snapshots that make up your table's history. So commits have unique identifiers, commit IDs, and you use those to reference historical points in time, and then you can review or revert to specific snapshots. So branches, tags, and commits give data teams a lightweight solution for data management that doesn't rely on creating or storing multiple copies of the data. Instead, it only stores the changes between snapshots, and that makes version control, collaboration, and data governance much easier. These are a few of the benefits, and just a few of the benefits that customers see using Dremio Arctic's data as code capabilities. The first is consistency, the ability to deliver a consistent view of the data across data consumers and analytic use cases by ensuring that you always deliver high quality production branch, and any changes to that data are thoroughly tested for quality before being committed. The next is experimentation. Data scientists, data analysts, and data engineers can all work on the same snapshot of the data. They can work independently of each other on separate branches without impacting each other's work. That experimentation can then be committed, or that branch can be deleted after the work is completed, and your production branch remains. Third is collaboration. So data as code gives data teams a really easy way to track, review, test, and revert changes if needed. So the data teams can work together, share knowledge, and coordinate their work more effectively. Next is governance. Data as code enables version control, auditing, table row and column level access controls, and automated testing so the data teams can manage data much more effectively. And finally, it makes reproducibility easier. All changes to the data are tracked over time, which makes it really easy to reproduce data pipelines. In a multi-domain architecture like a data mesh, for example, where multiple owners are building and managing different data products, they have the ability to quickly and accurately reproduce data pipelines, and that can accelerate the delivery of those data products. Now, before we get to the demo, I want to go through a few examples of how data as code can be applied to data management use cases. The first is an ETL branch for data quality. So if you create an ETL branch, you can then ingest data into the branch and not into the production data set. You can test it. You can fix any issues. You can run a dashboard and make sure that everything looks okay. And you can do all of that before merging that data into the main branch and impacting the production data set. Next is experimentation. You can create a transient branch. You can do SQL transformations on it. Maybe there's some ad hoc analysis you want to do. Maybe a data scientist wants to do some work and not use the production data set. You can do all of that in a transient branch without impacting the main branch in isolation. And then after you're done, you can either merge that into the main branch, or you can just delete the transient branch once you're finished. Next, we have reproduction, where you can query historical data by referencing a specific tag, commit, or branch. So model reproducibility is really important for a lot of data consumers, but it's especially important for data scientists who want to reproduce the results of ML models. So with version control, all changes to model code, training data, and hyperparameters are tracked over time. And atomic commits ensure that changes to models are consistent and reproducible. Next is recovery. So in a lot of data systems, returning to your production environment to a point in time prior to a mistake being made is extremely complicated. With Dremio Arctic, it is actually super easy to recover from mistakes. All you have to do is move the branch to a historical commit using the commit ID, and you can go back to the point that you want to return to. Finally, you can use Dremio Arctic for easy troubleshooting by using a branch or table level commit history to see when changes were made and who made those changes. And then you can, of course, recover to a time before a particular commit was made in order to troubleshoot any issues that your main branch might be having. So that's a bit of a primer on Dremio Arctic and its data as code capabilities. Now I'm going to pass it back over to Alex to show you a demo of some of those data as code use cases that I shared so that you can actually see it in practice. Alex, over to you.
Hello, everybody. My name is Alex Merced, and I'm a developer advocate here at Dremio. And today, what I'm going to do is take you through a demonstration of the Dremio Arctic catalog and how it introduces data as code. When we think about data as code, this is a new trend in the data world where essentially we're bringing many of the practices that we're used to in the world of software development with tools such as Git, where we can isolate our code by being able to code on branches, by being able to version control and be able to revert or reset our commits, being able to govern who can control who has access to pull and push what code via the tools that we have. Basically, that's essentially what we're bringing over to data. Okay, so essentially that idea of being able to isolate, version control, and governance to your data. Okay, and in this case, using a open source tool called Project Nessie that powers the Dremio Arctic catalog, which brings you all the awesome features of Project Nessie as a service, plus so much more. So we're going to kind of go through all of that today, and I'm going to take you through a demonstration of the Dremio Arctic catalog. Okay, so the Dremio Arctic catalog is a data catalog, and is a data catalog that works, of course, with Dremio Sonar, the query engine, but also works with other engines such as Spark, Flink, Presto, and more. Okay, so basically, you're able to keep your data consistent wherever your data lives. So let me go here. I'm here on my Dremio dashboard, and you can see here I'm connected to all sorts of sources of data. So when you're using Dremio Sonar, you can not only just connect to your Dremio Arctic catalog, which you see here under the data as code. I have several different Arctic catalogs that I'm connected to, but I can also connect to different metastores like AWS Glue, which I have connected here, and I can connect to all sorts of different object storage and many other places like databases. So again, I have all sorts of different sources I can connect to. Okay, one of the beauties of the Dremio platform, I basically can use anyone can bring in the data from anywhere and consume it anywhere. It's the Open Data Lakehouse, right? Okay, but using a Dremio Arctic catalog is easy as adding it to here on Dremio Sonar, as easy as just clicking on sources, choosing Arctic, okay, and then basically clicking here and saying, hey, I want a new catalog, okay, and you now have a new catalog right away. I could also go over here to new project, or go to my projects and say, look at my Arctic catalogs, and then create a new catalog from here as well. Okay, so I have several options on how to manage my catalogs, okay, or how to create them. But once I have that catalog here, like I have this Arctic catalog that I've called Arctic, I have a folder for our demo today, okay, over here on here, and we have these three data sets. So let me just kind of walk you through what's about to happen. We are a company that basically coordinates people who would like to be a virtual assistant with people who need a virtual assistant. So these assistants that want to be contracted out are under our assistants table, and our customers are under our customers table. Okay, so these are our dimension table, and then we have our fact table, the sales table that basically documents all our sales and which assistant provided the service for which customer, along with how much we made, etc. So what we want to do is we want to ingest the February sales data. So what we're going to do is we're going to head over to our Dremio Sonar SQL runner, where I can run SQL queries. Okay, and this is a great IDE experience. Okay, so you have all your favorite IDE features here, such things as like multiple cursors, dark mode, light mode, autocomplete. Also great features when it comes to writing your SQL. And then you also have here where you can easily grab any of your sources. So like let's say I wanted to like inject X source. So let's say I want to grab one of the sources for today and just put it in my query. I can drag and drop it like that, so that way I don't have to type out the whole namespace. And another way the Dremio SQL Sonar SQL runner saves you time is you can pre-write queries or templates for queries that you plan on writing a whole lot, or you running a whole lot and saving them as scripts. Okay, so essentially all the steps for our exercise today I have saved as different scripts. So okay, so basically when I wanted to set up the sample data for today, I had a script just for that. Okay, that basically creates all our data sets today. And again, just to show you that you can create scripts as well to basically make your life easier. And again, I can run multiple queries in a script. And now we get to where we are right now, where we're going to begin our exercise. Okay, so the idea is I'm going to ingest this February sales data. And what I'm going to want to do is isolate the work that I'm going to do to ingest that data. Okay, so what I'm going to do is I'm going to create a branch, and then I'm going to make sure that I do my work in that branch by using the use branch statement that basically says, hey, going forward, any queries past this query will be in the context of that branch. Okay, then I'm going to basically copy over my, or ingest my February sales data, and then what we're going to do is we're going to merge that February sales data with our sales table, so that way it's all there. And then we're going to show you that it's isolated by running a query of the count of tables from our branch, and then running it from the main branch, that's the production branch that our data consumers would be querying, okay, to show you that, hey, look, those changes have been isolated. They have not affected our main branch. Our main branch still only has X number of records, and so forth. So I have all these queries that I had saved in a script, all ready to go, and all I have to do is hit run, okay, and it's going to run each of those queries one by one, and again, it's going to create a tab for each query as I go. So that way I can easily see the results of each query by just clicking here and here. Okay. Now one thing you always want to keep in mind is you want to make sure that your cursor is at the beginning, because that's where it's going to start querying. So let me run that again. Okay. And there you see like all the jobs are up for being queried. Okay, and I can see there's a tab for each of the queries that are in this script. So it's running through them. So again, basically switch branches or created the branch. It's using the branch. It is now pulling in the data. Okay, it is now merging the sales. Now it's running the count queries. Okay, so that way we have our two counts, and then we'll be able to see the results of these queries. Okay, so I can already see the results of the first count. Okay. Oh, that's over here. Okay, and you can see when we queried the count of records in our branch. So this is on the isolated branch, the demo branch. Okay, we have 20,000 records because we just added 10,000 records from our February sales data. But if I take a look at the query from the main branch, our main branch still only shows 10,000 records. So we can see that the change was isolated. It did not affect our main branch. Any data consumers currently querying are still only querying the data from before this work that we're doing. Okay, The beauty of this is that basically I can make sure that I can run my quality checks and audit the data before my consumers consume it. Because why does that matter? Data quality means insight quality, and insight quality means business value. Okay, it's the basically quality of our insights are going to be determine the business value we get from the decisions we make based on those insights. So we want to make sure our data is quality. So we want to make sure we have the processes so that we can manage that data quality. So to give us the space to audit that data, the space to roll back any mistakes we make, and so forth. Okay, so we did that. Okay, so we showed that. Now, next thing we're going to do is we're actually going to run our checks. We're going to actually like audit the data. So I'm going to make sure that I'm still in my branch. Now, notice here, I'm not writing out the whole namespace. So in the previous script, I was writing out the whole namespace for each query. Okay, that's a lot of typing. Now, a nice thing about the Dremio UI is that what I can do is I can click over here where it says context and then set the context for which all the queries will be run. So in this case, I really want to set the context into that folder where these data sets exist. Okay, so I'll select that folder. Okay, and now I don't have to write out the whole namespace because when I just write out sales, it's going to assume that it's in the context that I specified. Okay, which makes writing my queries a lot cleaner and a lot easier to reuse, especially when it's a script, because I can just switch the context as needed. Okay, so again, just a lot of these nice features in that Dremio UI experience. So in this case, I'm again switching to our branch, and then I'm going to do an integrity check. Basically what I'm doing is I'm running a check on what's the count of all the records in the sales table. Then I'm running a count of all the records that have a matching assistant and a matching customer to make sure that all these foreign key references actually have matches. Okay, I want to make sure there's no mistakes. We're going to do this twice. So first I'm going to do it. We're going to see that everything perfectly matches. Then we're going to intentionally insert a record that's not going to match. Insert a bad record. Okay, and then we're going to check the referential integrity again, and you're going to see that, we have a problem. Okay, so let me make sure I set my cursor over here at the beginning. Okay, so that way it runs all the queries. I'm going to hit run, let it begin running those queries. Okay, and then we're going to see the results. So again, now we see we have the first count. Okay, so when I click here on the first count, we see that I have a fact sales count. That means my total sales of 20,000. And then the amount, my referential integrity count, so the ones that actually like have, matching foreign items, okay, also equals 20,000. So everything perfectly matches, meaning, everything's good. But now here in query 3, we added one record. And now here in query 4, I do that count again. And now I notice, hey, look, I have 20,001 records, but only 20,000 match. That record we just added doesn't have a match. We made a mistake. Okay. Now, normally, chances are you're making a mistake not just with one record, but with several records. And then you run into this whole problem having to kind of determine, hey, what records were the problem? Okay, and having to go hunt them out and prune them out and fix that up, which can sometimes take hours of work. Okay, and then sometimes having to go back and backfill data. Well, thankfully, we're using Dremio Arctic. Okay, so it's just simple as me going and rolling back or reverting and undoing the mistake that I've made. Okay, and the way I can do that is by basically changing the commit my branch is pointing towards. I just have to find the commit ID that I want to go back to. Okay, so here in this script, we're going to see that, hey, I switched. I'm always making sure that I'm working from my staging branch. Okay, I'm going to do the referential integrity check again, so that way you can see that there's still a problem. Then we're going to go back, set that branch back to a previous commit. So all I have to do is find the commit ID. Okay, and I'll show you how easy that is in just a moment. Okay, and then we'll do the check again and see that we fixed the problem. So for me to find the commit ID, and this is one of the nice things about using Dremio Arctic, is that you have this nice UI to inspect your Arctic catalog. So if I go over here to my Arctic catalogs, open that up in a separate tab. Okay, I can go over here, take a look at the Arctic catalog that I'm currently working out of. And then here, I'm able to like switch branches, so I see which branch I'm inspecting. So I'll take a look at the branch that I'm currently looking to work out of. So here, demo 22923. I'm going to say, hey, that's the branch I'm inspecting. I can see all the tables in the catalog from that branch. I can see all the commits from that branch's point of view, any tagged commits. I can take a look at all my branches and do like merging and create new branches all from here. But I know that the commit that is the problem was my most recent one, because that was the most recent change. So you see here, like that, I put data to the sales table. That was me inserting that record. What I want to do is go back one commit. So I'm going to copy. So that's basically I want to not point here, but point here. So I'm going to copy this commit hash. So I just click copy commit hash, and then I can just plop that in right here, and I'm good to go. Now, of course, you want to always make sure that you're pointing at the right context, okay? Because again, I'm not typing out the full namespace. So I got to go make sure I set my context to point to the right place that the context of these particular tables are. Okay, so I got my good context. I'm pointing to the right commit hash. Everything looks good to go. Let me just make sure my cursor's right here at the beginning. So it runs all the queries. I hit run, and it's going to begin running the queries. So again, it's switching branches. It's going to do that referential integrity check. Okay, so when we take a look at the referential integrity check before we do the assign, we see that, hey, look, we still got the problem. Then we're going to assign the commit. So you see this was successful when I click on query 3. And then when I click on query 4, I see, oh, look, they match. Okay, the problem is gone. Okay, wonderful. Okay, so basically it was simple as that. I just went back in time, back to when I know I have clean data, and now I can re-add the data correctly this time. Okay, no headache, no stress, and again during none of that time was that data exposed on the main branch, so no inconsistent, incorrect data was being exposed to our data consumers. Okay, so again the beauty of that isolation, the beauty of that version control, making our life a lot easier, a lot less stress. But another really cool benefit of being able to isolate at the catalog level, okay, is that I can do transactions on multiple tables. So in this next script, what we're going to do is we do have one assistant who just joined our staff at the very last minute. Okay, they just literally joined in the last few days, so they weren't reflected in the data that just came in. Okay, so my list of assistants doesn't reflect this new hire. And they just did a job really on the last day of February, so that job wasn't reflected in the sales data. It was just the very last minute. Okay, they didn't get processed in time. So I'm going to go manually add it in there. Okay, so I'm going to go switch to the branch because again I want to do all my work on my branch, keep it isolated, and I'm going to insert a record into the assistance table and then add the sale to the sales table. So that I have to edit 2 tables. And again, the change to the sales table depends on the change to the assistance table because of that whole referential integrity. Now again, if this were not isolated, then when I make the change to the assistance table, it could affect queries that are on the sales table, and vice versa. Okay, but this way I can make changes to both tables and then publish them all at the same time as just one big atomic commit. Okay, this is also known as multi-table transactions, a pattern that previously was really only available to data warehouses. And again, another thing to point out, how nice is it for me to be able to do all this branching and merging straight from my SQL? So notice I haven't had to switch to a Python script or a Java, a Java jar or anything like that. I'm doing this all in SQL, straight from the Dremio UI, being able to switch branches. And it's the same thing if you were using Flink, same thing if you're using Spark, same thing if you were using Presto. You could do it all from your SQL. Okay, so making basically this kind of dataascode, this level of engineering, much more accessible, to more people, so you can get that work done. Okay, and they can all do it simultaneously from different tools. How cool is that? Okay, but basically we're going to add that record. Then we're going to make sure that we do our referential integrity check to make sure that everything still works. And again, I want to make sure that I always set my context because again, I'm not writing out the whole namespace, so I got to make sure I set the context properly. So I'm going to say artic into artic demo 2923, select. Okay, and now I'm going to make sure my cursor is at the beginning of the box. I'm going to hit run and let the queries run. Okay, and then here we go. It's switching branches. Okay, it's inserting those records. So I can see that the records were inserted successfully, or at least the first insertion. Now we're going to see that the second insertion is going to be done successfully. So there it is. Okay, and then it's going to do that referential integrity check, and we'll be able to see that, hey, look, we still have referential integrity. Our data is still good. Okay, and we can see that right there, 20,001, 20,001. Everything is a-okay. Okay, and for the final stop in our tour, okay, I'm going to head over to publish our data. So we're going to head over, and what's going to happen is we're going to actually see, again, show you that the data is still isolated. So before we do the merge, I'm going to do a count on the sales table from both branches. So you can see that, hey, look, the main branch still only reflects 10,000 records. And then what we're going to do is we're going to merge our staging branch into the main branch, okay? And then after we do that, we'll do the counts again, so you can see that afterwards, now they're in sync. Okay, all those changes have been brought over. They are now published for all my data consumers to consume. Okay, so again, I will make sure that we set the correct context. Okay, always make sure you do that if you're using the abbreviated namespaces. Okay, so right there, select the name context. Make sure I put my cursor at the beginning of the box. I'm going to hit run. And there we go. It's going to start running all those queries. Again, now I'm bringing and publishing all that data. So again, all I had to do was first write the data. I ingested the data. Okay. I audited the data there from a branch, and then I published it by merging it back into my main branch. Okay. And basically, this allowed me to have the peace of mind that no bad data is being queried by my data consumers. And again, just to kind of show that, so if I go over here and take a look at our first count, so in our staging branch at the beginning, we had 20,000 records. And in our main branch, we had 10,000 records. So that was before the merge. Now, after the merge, okay, our demo branch had 20,001 records, and our main branch also has 20,001 records. Okay, so we have successfully published all that data after running our quality checks, using version control to be able to revert to previous commits when we made mistakes, and make sure that we have high quality data provided to our data consumers, so that way they can have high quality insights, so that way they can provide business value, okay, which is always the end goal here. Provide business value. Business value comes from quality data, and data quality comes from being able to use tools that give you the space and the mechanisms to be able to do that, to manage that data quality. So my name is Alex Merced, developer advocate here at Dremio. This has been a demonstration of the Dremio Arctic catalog. Again, the Dremio Arctic catalog can be connected from multiple engines such as Spark, Flink, Presto, and more, along with Dremio Sonar. Again, you can get a Dremio Arctic catalog at a click of a button right here on the Dremio Cloud platform. So no harm to try it out today. It can make a big difference in your data quality and the quality of your business insights. So have a great day. I'll see you all later.
Okay, so hopefully you guys all enjoyed that demo. So now it's time for Q&A. So we already have a couple questions, but if you have any additional questions, do leave them in the Q&A box below. I look forward to going through all of these. So for the first question that we see here, it says, can you do this via API or via dbt Dremio? Ideally, we would not want to manage this data manually via UI and as part of the daily data load and CI/CD process. So first, I'll give you the quick answer, yes. But just to kind of elaborate on that is the ideal world is to really kind of capture that CI/CD world, that continuous integration, that continuous deployment where we're automating these things. So all these SQL statements that I did manually in this demo just shows you that what the commands are. But at the end of the day, like Dremio has many ways in which you can send it SQL statements. So now we do have that Dremio dbt connector. So any valid SQL that Dremio supports that can be sent via that connector will work. So that would be including all this data as code language. But also built into Dremio are different ways to connect. So you can send queries via REST API, you can use Apache Aeroflight, you can use JDBC. And so theoretically, you could write a script in the language of your choice using these methods of connection, and then set them up as like cron jobs or as a web service to help automate that process. So recently at our Subsurface conference, I kind of drew a picture of this one possibility of where you might have data that lands in S3, and then what you do is you trigger like a Lambda on AWS that triggers when that data lands, which then sends a request to a web service that then automates all these processes via the REST API. Okay, and then in those processes, not only can you run all these commands, but let's say you're using Python, then you could even use other libraries you may really enjoy. So maybe you enjoy doing a lot of like data quality verification using something like Great Expectations. You can then also run queries, get the data, run it again, do your Great Expectation checks, and then choose to whether you merge or roll back based on the results of that. So essentially, like, it's very automatable. There's many different methods, and in the future, more and more tools, build in the more Dremio integration, and a lot of ETL tools and orchestration tools already have Dremio integrations. Again, anything you can automate it, because that's the beauty of it being done via SQL. Any valid SQL being sent to Dremio will be executed just fine. So any tool that allows you to automate sending SQL to Dremio will allow you to automate this data as code processes. That's sort of the beauty of this particular level of abstraction, where we can do that in the SQL versus other similar offerings that don't have that sort of SQL access point. So hopefully that answers that question. Again, if there's any other additional questions, just put them in the Q&A box. And if anyone's going to Data Council, in a few weeks, I will be doing a dataascode workshop at Data Council. So I'll be doing another, not this exact demo, but a different demo where we'll walk through setting up Dremio Arctic, connecting it to like a Jupyter notebook and running some queries and doing some data visualizations. So if you're in town for that in Austin, Texas in a few weeks, do meet me over there. It'll be a fun time. Cool. Okay, I guess the demo answered most questions.
It was super clear, Alex.
Thank you, and same to you. So, and again, Jeremiah, thank you for joining us today on Gnarly Data Waves. It's been a good time talking about one of my favorite topics, dataascode, because it's exciting times in this data world. We're mixing some of my favorite things, data and code. So yeah. So here we got a question. When we hope to get the CI/CD solution in Dremio, now as far as like something natively in there, in Arctic, I want to say in the near to medium term, you'll start seeing some of these features kind of built into let's say they're imminent. But these are going to be features where you can actually automate some of these things, like optimizing your tables that are in your Arctic catalog, being able to run compaction, cleanup, stuff like that. So you'll be able to automate certain types of cleanup work on your tables. And now, as far as like scheduling, being able to schedule SQL directly from Dremio, that is actually something I'm checking with right now. So I don't have an answer for you at this moment, but I am checking with the product and engineering teams on when I could expect that. But again, you never have to wait, because at the end of the day, Dremio gives you so many different ways to connect via REST API, via Apache Aeroflight, the integrations with all these different ETL or orchestration tools. That as far as like automating these things and creating those CI/CD pipelines, you can do that today. It just, in the future, you might be able to do that from the Dremio UI, but today you can already do it through, creating web services, cron jobs, using orchestration tools, ETL tools, basically anything that can connect to Dremio. And Dremio has the interfaces for any tool that doesn't have those integrations yet to build those integrations. And, we're always here to help for anyone who wants to build those integrations, those tools. Okay, can you connect to mainframe, data, DB2, IDBMS? There's different connect now. If you're using Dremio software, so that means you're using Dremio on-prem. There are official connectors, and I think we may have just released the DB2 connector, or it's on the very near-term roadmap. But that exists, and there's also community connectors. So I would check. If you're using Dremio currently on-prem, I would check with your AE to see, if they can help you find out which community connectors are available and what connectors are immediately available. Now, if you're talking about Dremio Cloud, the connectors you see when you log into Dremio Cloud, that's what it can currently connect to, but that's going to be continuously expanding. Like we just added a Dremio to Dremio connector and a Snowflake connector. So if you have data in Snowflake, you can now query it from Dremio and join it. So imagine now we live in a world where with one platform, you could take a table from Snowflake and join it with a Delta Lake table you made on Databricks. You can do that with Dremio. That's a thing. So check that out. This is a great learning session. Okay, that was just comment. What would happen if an Arctic table I use create or replace table as select query? Does it create a new iceberg table, or do we have to explicitly insert new records in the Arctic table? What would happen if I use create or replace table as select query? Does it create a new iceberg table? I mean, it'll just do what that query would normally do. So it'll create, if the table doesn't already exist, it'll create it. Otherwise, it'll replace it. So it would just, that's a good, I'm just trying to think through what the mechanism would be. Like, I assume it would just initiate a new table. Now, according to like the way the Arctic catalog works is that every time there's a commit, it's essentially creating a snapshot of all the different tables and the metadata file that it's pointing to. So if you did that, I assume it's going to create a new table. So it's going to create a new metadata file and new data files, but it's not going to delete the old files. So old commits should still point to the old version of the table. And if if this was on a branch, the main branch should still point to the old version of the table. But that again, that new metadata file wouldn't have the metadata file for the iceberg table itself wouldn't have those historical snapshots because it's a new table. But again, that doesn't affect the catalog level snapshot, because the difference between Arctic and Iceberg itself is Iceberg tracks snapshots at the table level, Arctic is tracking them at the catalog level. So even if you created a new table, you'd still kind of have access to that history via the catalog level snapshots. But I want to verify that, but thinking through how they both work, that's what I would expect to happen. But I will do some legwork to verify it. But so essentially you wouldn't necessarily lose the old table until you do cleanup operations. Oh, we got another one. Data is coming from many sources, so they consistently change, and we do not need a source control for this data. Could you show one of the use cases when we need source control of data? I mean, there was 5 use cases that Jeremiah pointed out earlier, and I mean, it depends on whether those use cases apply to what you're doing. So again, you may be having data coming in from many sources, and you may not need to source control the data for ingestion. But if you're running like ML, you may still want to create a tagged branch, so that way you can make sure that you are testing those ML models against consistent data. So that way, if you want to test, hey, changes to that ML model a month later, you're testing it against the same exact data that was tested against a month earlier, and things like that. Or someone just wanted to do some ad hoc experimentation with the data. So it has nothing to do with your ingestion work. So you may not need that isolation for ETL, but again, for things like experimentation, replicating ML work, and also just for the benefit of having that safety of rollback if there's a mistake. Because imagine you make a mistake where you accidentally ingest the wrong data into 1,000 tables. Being able to just roll back all 1,000 tables with one click is nice. That definitely saves a weekend. Versus, I mean, now Iceberg just introduced branching at the table level. The difference there is that that's per table. So essentially, if you make a mistake with 1,000 tables, you could still roll back at the Iceberg table level, but you'd have to do it one table at a time. With the catalog level abstraction that Arctic provides or Project Nessie provides, you can roll back the entire catalog in one command. So that means the mistake for all 1,000 tables can be rolled back one command. And that's pretty nice, especially if you ever had a long weekend backfilling data. So that would be a nice benefit. Does Dremio support all formats of RDMS and NoSQL? Well, I mean, the number of SQL and relational databases is constantly expanding. So we try to add as many connectors as we can, and we're constantly trying to add more. But every time you think you have all of them, new ones come out. So I can't say definitively all of them, but pretty much all the most used ones should be covered. And that list is constantly growing. And then again, if you're using software on-prem, or the software version of Dremio, again, there's a lot of community connectors as well. And then again, the Dremio cloud connectors are constantly expanding. So with that, I want to say, again, thank you, Jeremiah, for coming on and giving us that delightful presentation on dataascode and Dremio Arctic. Thanks, everyone, for coming this week. Again, next week, if you want to know about ingesting your data into Iceberg using Fivetran, come by next week. And then the week afterwards, we'll talk about optimizing those Iceberg tables and then Iceberg office hours. So if you really like Apache Iceberg, the next few weeks are going to be some really great content for you. And then again, this will also be available on iTunes, Spotify, YouTube within 24 to 48 hours. So if you want to share with a friend, there you go. And again, if you're going to be at Data Council in a few weeks, I'll see you there. Thank you very much. Have a great day, and I'll see you all next time.